as I look in front of us at our challenge in decarbonizing the industry and decarbonizing buildings, particularly existing buildings, because even in 2050, that's going to be the bulk of what the built environment really is, even with new buildings coming over the next 30 years. It takes being able to look at the building enclosures and look at the building systems and think about where the renewable energy is going to come from and how much can be on site and how much is going to be off site, and putting those three things together is not how our industry, as our industry has grown. And when I say our industry, I'm going to say our energy efficiency industry. So our sector that has really been focusing on this stuff for a long time. I mean, really starting sort of when I began, so 40 plus years ago, has gotten more and more specialized. And so if you are a homeowner or a business owner or a municipality, and you, for some reason, you've got the bug about decarbonizing your building, and you go looking online, you can call someone who's a weatherizer, or maybe building contractors who are specialized and know a lot about enclosures. And you can call an HVAC subcontractor or an HVAC engineer and get a new mechanical system design. Then you can easily call a solar contractor and get a proposal for solar. And then how do you know if you have spent the next dollar in the best place? And that's the crux of it, because well, how much PV do you need? Well, you need PV to drive the use of the building. If it's a small enough building that you can drive it off the skin of the building or the site. Well, how big is that load? Well, what's the building right now? What does the enclosure look like? Where's the energy going now? So if you can drop the load in the beginning, then the systems will be smaller. And if the systems are smaller, they cost less. And so that money flows to the enclosure. And that's not new. I mean, that's been part of how people have been thinking about new construction, for sure. Let's spend less money on the mechanical systems and more on the enclosure. And I mean, in a way, that's if you look at the genesis of the German passive house movement, that's what they were saying. They were saying we need to spend more money on enclosure and less on systems. So, and then if you drop the load and the systems are smaller, the renewables to drive it are smaller. So where's that optimization amongst the three-legged stool of thermal enclosure and other loads, mechanical systems, and renewables? And I think getting people to become more generalists, or getting teams together that can be more generalist, is important. And then one of the other things I'm seeing that's kind of interesting is there are super skilled people at building modeling and for instance, but most of their experiences with new buildings, or their experiences with an existing building that's going to get completely done over. So a real deep energy retrofit, which is kind of a new building. And so right now in my town, we put out a request for proposal, and we have a team that got contracted to look at our school, which is about 65,000 square feet. People who have, either taken my deep energy retrofit course or look at some of the free courses that we have on HeatSpring, have probably seen something about the Plainfield, New Hampshire school that I worked on in the aughts. And one of the things we asked people who were responding to this proposal is, show us other instances where you've done this, and there was almost nothing, right? So we did that project a dozen plus years ago, and it's to pull all those things together takes a lot. And so I think we actually hired a really good team, and yet I've still been sort of I'm not actually on the committee that's interacting, but I'm kind of a consultant to the committee, and I know the team people. And so I've been kind of pushing them on, you know, you need to, for instance, you need to do a bunch of blower door work in that building, and you need to understand where the air leakage is. And I think they understood that, but they sort of still ask, why is that? And I said, well, when you start looking at some of these buildings, and I have found this to be true, particularly of like 100-plus-year-old masonry historic buildings, you very likely are not going to have either the budget or the latitude to fix the walls in those buildings. Mm-hmm. If they're bare or they're getting a complete redo, and I've done a number of buildings like that, then you can work from the inside. You can't touch the outside, it's historic, right? And we have hundreds of thousands of these buildings across North America. So you say, well, you can work on the inside. Well, let's say it's a city hall. Just thinking of one more recent project. The city hall, first of all, people aren't going to get out of it. It's a job to get people out of there, right? And empty the building. And then it may be a building that has beautiful finishes on the inside. So let's say now you know the building's leaky. You can work in the foundation area. You can work in the attics, the roof, and you can add insulation and air seal it. But you're not going to touch the walls. And let's say you can touch the windows. So how are you going to model what the infiltration starts at and finishes at? Because you didn't touch every square foot of the building. And to me, if I'm touching every square foot of the building, and we talk about this in the deep energy retrofit course, then I'm setting a goal that's equal to my new construction goal. But in cases where I can't touch every square foot, I really have to understand, where's that leak now? And which ones can I deal with? And which ones am I going to have to let go? What most clients care about is, and this is just one of my favorite expressions, where does the next dollar buy the most value? Where does it return the most for you? So that's a generalist question. So at least the person sort of that is running the project wants to be able to pull those pieces together, even if they are working with a number of specialists.
How many folks are you finding to be generalists these days? Is it a lost art? Is there not very many?
So I have an opinion, like I have on many things, and most of them are wrong. This past year, I was on the content committee for the Northeast Sustainable Energy Association's annual Building Energy Boston conference. And in the old days, I used to be on that pretty much every year, but I hadn't for a long time. So there were two old guys on this group of maybe 30 people. And I really thought, wow, these young people are so smart and they know so much more at their age than I knew. But they all have jobs. And when in October last year, there was a gathering of all the people who had won the Nessie's Distinguished Service Award. So these are older people, men and women, sort of my generation mostly. And I looked around and I realized that almost everyone there had their own company. Because 40 years ago, 35, 40 years ago, if they wanted to do this work, there weren't jobs. They had to, we kind of invented it. And so when you start your own company and you're in the early stages of an industry, you have to be a generalist. So I did a bunch of energy modeling when I was young, but that wasn't all I did for sure. And now on this team that's looking at the school that in my town, there's a young woman who I think is probably really good, who's an energy modeler, and that's what she does. And I was saying to them, you know, you don't need to use a really heavy duty energy model for something like this, because there's a bunch of stuff you can't get that right as inputs anyway. So you're really looking at comparative stuff. So I don't think you need to use what Andrea's really, you know, proposing here. And they said she does it every day. So she's got all kinds of libraries, and she can use that heavy duty tool in a very expedient, quick way. I never learned that because I felt like to use some of those tools, I would have to be doing it 20 plus hours a week. And I was doing a bunch of other things too. So it's that. So yes, I think people are much more specialized. There weren't HERS raters, right? There wasn't Building Performance Institute. There wasn't Passive House, let alone LEED or Living Building Challenge or WELL. And so people have become specialists. You know, the Living Building Challenge has this very, very rigorous material selection. You can't use materials that are on this thing called the red list, which includes just about everything that isn't like metal or wood or or masonry. And there's like a whole subgroup of consultants now that help you get through the red list. Like, who would have thought of that, right? And so when I look at a material, when I'm choosing a material in a building assembly, I'm looking at its toxicity, just like them. And I'm thinking about it from the point of view of the people who are manufacturing it or handling it in some way, the people who are putting it in place, the workers, and then the occupants of the building. So there's really, you have to think about all three of them, because there's some things that are very benign for the occupants, but were toxic in their manufacture. You know, spray foam is a great example. The foams are a great example of that. They're not a problem in the building, in my view. So I'm looking at toxicity. I'm looking at where it comes from. I'm looking at its embodied carbon. I'm looking at how it's going to perform. Like, what's its durability? So there's all these different things that I'm looking at. Once I become a specialist in material toxicity or embodied carbon, am I looking at any of those other things? You know, and am I recommending materials that are really good at one thing and are going to be poor at another? And Brett, these are not theoretical questions, because the company that I worked for a while here in Martha's Vineyard, a design build company, built this whole deck. And the structure of the deck was this new, highly touted material that was replacing pressure treated wood. It was a type of wood and a type of treatment, and far more benign in terms of toxicity. Yeah, and 7 years later, it was on the ground, and it cost $70,000. It was a big deck that wrapped around the building, and it cost $70,000 to rebuild it. So the person that's only looking at toxicity is not taking the whole view, right? So that's, specialization is both a great thing, but has to be managed by generalists.